Hello and good morning. In unit number 5, we are going to discuss various antenna types. So this unit is divided into two parts where we study different antenna types. But in the first part, a short electric dipole and a small loop antenna. These two antennas are studied in detail, where we find the fields, derivations for fields of a short dipole, we find the expression for radiation resistance, and same procedure we follow of finding the field pattern and radiation resistance and directivity of a small loop antenna. So short electric dipole and small loop we study in more detail with equations, whereas in the second part, there are 9 different types of antennas which we study briefly only with the construction and their design equations. Few design equations, not all the design equations in detail, but few equations which are important in designing these particular antennas and their, of course, construction. So the types of antennas we study are listed here. You can see patch, which we have studied in the laboratory, helical, which looks like a shock absorber, helix structure. Then there is a corner reflector. Parabolic reflector is nothing but the dish antenna which we use for the television. Log periodic antenna, embedded antenna. We do not have any design equations in these 4 topics. In embedded antenna, ultra wideband antenna, intelligent antennas, and there are antennas for remote sensing. So let's begin by introducing you first to what is a short electric dipole, because any type of antenna that we consider here is consisting of a short piece of conductor which is known as a short electric dipole. We have already studied the concept of electric dipole. Let's study it in detail now. So as I mentioned, any linear antenna is considered as consisting of large number of very short conductors connected in series. The best example of this is to understand the old television antenna, which we call as a Yagi-Uda antenna. It is the best example because we see clearly that there are many conductors, they are connected in series, and thus the entire antenna structure is built. So it is interesting to understand the radiation property of these short conductors first, and then from the knowledge of properties of these short conductors, we can build the pattern of the entire antenna structure. So a very short linear conductor is often called as a short dipole. Short means the length should be very small than the wavelength of the signal. So in our discussion, we always define a short dipole as a finite length, even though it may be very small. So when L is very small than lambda, we call it as a short dipole. You can see a typical structure of short dipole is shown here. There are 2 plates at the 2 ends. In fact, it is only one conductor and there is a transmission line. Transmission line is not part of the antenna. Antenna is only consisting of this small conductor of length L. The diameter of this conductor is still smaller than the L. So it cannot be considered in the analysis of antennas. The length of antenna is L, which is very small than lambda. And these 2 plates at the 2 ends are provided in order to offer a capacitive loading. Now there is a possibility that the current that is developed through the antenna can be resulting into overloading at the 2 ends. In order to eliminate that overloading, a capacitive loading is provided so that at both the ends we get some support in order to provide a uniform current I along the entire length L of the dipole. Now when I say uniform current here, if we remember unit number 1, we have studied radiation happens from a current which is in the form of simple harmonic motion. So uniform current here indicates that it's a small dipole. The length of the dipole is very small. So if we consider a length of the dipole L, uniform means that at any point if we measure the current at point 1 or at the middle of the dipole point 2 or at the point 3, far away from the antenna, then the current is constant. That is meaning of uniform. Let's say the measurement is done at point P, then the important point to note that whether we measure current at point 2 or we measure the current at point 3, it has to be same. That is the meaning of uniform. The diameter of dipole is very small, as I mentioned, so it can be omitted from the analysis. And the thin conductor length L with uniform current I, with current of course because of the point charge Q, is defined as the rate of change of Q charge with respect to time. So in the next lecture, we will derive an expression for the electric and magnetic fields that are generated from a short dipole at a far distance from the antenna in the far field. Thank you.